uh, I actually got to class very early today, so I'm sitting in the classroom. Yeah, I'm sitting here. Sorry, buddy. Like,
That on camera too, me being dramatic.
huh?
That on camera too, me being dramatic.
It's like, I think it's zoomed in, so like, whatever I got.
Oh, so you saw like nose hairs. There we go. Let's try this.
Yeah, that's good. It's so hot.
It is so hot. Oh, did you move these chairs?
Huh?
Did you move these chairs? I didn't know if maybe in like a previous video you saw they were blocking the bottom of the board.
Well, if so, that would be what I would do.
Did you rework the problem she gave back to us?
I think I approached it and gave up. Well, I didn't give up, but I moved on to finish the two previous ones, 6, 1, 11, and
I'm getting ready to see if I can solve it in 10 minutes.
okay.
Because I had to do E&M, so. My snake. So that didn't happen. Ooh, I need more paper. 8 minutes. Did you make any progress on E&M?
No. So it's gonna be another disappointing, shameful day for me.
This one wasn't bad. I didn't feel like.
I always feel like a guilty dog every time, like, you know, I don't
He
have
yells
the
at
horse
us.
turned in. You know how like a dog, you know, like you like look at him and you know, you like know he like did something bad and he's all quiet and like looking down. That's me.
It's because it's our fault from last semester. Kind of like said it once last semester and then left it alone, and like I think the high score on the midterm was like a 30,
Yeah.
and basically now he's beating us up.
Well, he should. Yeah. But,
He's not wrong. Oh, it's all melting because this room's so hot.
we just need to be stronger. Yeah, no, I have no excuse.
I'm about to tell Dr. Yu I'm going to go home and put on my bathing suit and come back. That's just absurd.
What are you waiting for?
Seeing if the thermostat is hidden somewhere.
Oh, what do you want to do? We should set up this hot box too.
I should go have class outside. It would be better than this.
Oh my god, I forgot about the noise.
Sorry.
It's not your fault. I've just become so used to it that, like, you know, when you open up more windows, yeah.
You're reminded.
Yeah, I'm like, oh my god. It's like when you think about breathing and then you're actually like fixated on breathing.
Dr. Yu, we have to cancel class.
I'm sorry, I'm such a big disappointment after you. I still don't have it down. Hello.
Hi.
Hi.
Your energy.
It's so hot in here.
Yeah. They changed. Maybe tomorrow it's going to cool down.
I think it's supposed to be like
It is
75 again tomorrow.
Really?
Yeah.
Ah,
Should we be concerned? Nobody outside seems to be concerned about that.
no.
Blood curdling scream outside.
There's nothing out of the ordinary.
Dr. Yu, I have to leave a little bit early today.
No problem. Yeah. Okay, so homework done?
Almost.
Almost.
The third one is almost. I forgot how many parts there were to the third one.
The third one has a lot of parts.
Yeah, the third one,
Yeah.
you mean the 18, right?
Yeah.
Yeah, lot of. That is cover all you learned.
Yeah,
Yeah.
yeah.
I
So,
think I made a mistake somewhere. I don't know. You don't know what.
okay,
I
let
made a
me see. You
mistake or
just
not.
give it to me and I'm going to check.
Yeah.
Thank you.
I didn't get to rework the last one because I had to get my E&M done.
Oh,
Turned
okay.
in.
But you start work on that or?
I have what I had at first, which was the infinitesimal.
Okay, some, okay.
But
At least you have some credit.
yeah.
So the
Thank you.
infinitesimal or the finite, the better way to go about it.
Finance
The
better.
finite better.
Yeah, infinitesimal is fine, if you work on that. The finance is because it is different, right?
Yeah.
Just train yourself to do the exercises, so next time when you meet this type of question, you know how to do that. That is my goal.
Yeah, I'll work on
Just
the finite.
sweating.
Build up yourself.
It's a nice day out.
It's a nice day out. It's a horrible day in.
Let's have class outside today. What do you think, Dr. Yu?
Sorry,
Do you want to have class outside today?
Can
we
you
can
do-
bring our blackboard to outside.
Dr. Yu sitting there scratching quantum into the dirt.
Yeah, I'm nervous. And
We'll
you just
all-
look at the audience.
We'll all hold the whiteboard and Jacob will film.
Okay. Let's go. Please take a- That's a good idea. You will show others. This is a good classroom under the sky. Good. Yeah, I know this. Thank you. We're going to discuss how to obtain or calculate this Davis Golden coefficient, which is we determine first place. We have the two limit. One is the m is so maximum, gx maximum. Both are maximum. There's two limit case. Then I think the second one is we develop the recurrent. Sorry, but I think recursion relation, right? Relations for other cases. It's two limits, we know that the coefficient is 1. For others, we need the relation. So first one we already derived. Just remind from two. Use the 2 plus minus. Just equal to 2 plus minus equal to 0, 1 plus minus 2 plus minus. So from this relation, we have the right-hand side. We have 2m. We apply this formula to this. You already have it, but just to summarize, let me go to the next one. Is H bar 2 minus plus m 2 plus minus m plus 1 2 m plus minus 1. And on the right hand side, is this part. 2 So we have the first. Relation. Just because they are equal, right? So first relation h by h got cancelled. This term 2 plus 1 minus plus and 2 plus minus n plus 1. Equal to 3 minus plus. You can use chair.
We have to pay
It
back to it.
was too hard, right? Maybe the air flow. This is like, I think that we did in the last step. Okay, now we keep continuing. We are going to obtain another one. So these two are important. So from this now, if we say it's A, so we get the first recursion relation. Now B, we're going to take from this one, G1, G2. Same thing, but now this is the m minus 1, m minus 1. So from this G1, G2, m1, m2, G plus minus, apply G m minus plus 1. This is a Gm minus 1. And that's equal to G1, G2, m1, m2. Now G plus minus G1 plus minus plus G2 minus plus. This is G minus plus 1. Right? So we are going to use this relation and get the second one. Now, again, let's look at the first right-hand side. This one's the right-hand side. Right-hand side, let's do this. So we have a G1, G plus minus Gm minus plus 1. G plus minus apply this. So we have H bar. Okay. H bar now. G. Okay, right? G minus plus. So G minus plus m. But now this m is m minus plus 1, right? This m, since we applied m, so this is a G minus plus m. But here, all m or m prime is m minus plus 1. The second G, here plus minus m prime, which is m minus plus 1 plus 1. And then this coefficient here, G1, G2, M1, M2, G. Okay, M minus plus 1 plus minus 1, right? This is it. So see here, G minus M plus 1. G plus M plus 1. So this is G minus plus M plus 1, right? Whatever to minus over 1. So second one, G plus minus M. Now minus 1 plus 1, right? And this cancel. Okay. And this is G1, G2, M1, M2. And here, M minus 1 plus 1 cancel. Plus 1 minus, so that is M. G2. Okay. See here, this one, you can get from here, right? Or it is G. Okay. All right, so let's first, this is the right hand side, so now right hand side, we're going to use G plus minus, G1 plus minus 1 and minus and G2 plus minus 1. G1, G2, M1, M2, G1 plus minus plus G2 minus plus G1 minus plus 1. Let's do this. Here, and when I did this, I didn't pay attention, but I think you remember that. So if we have, that's the two information we need. G plus minus dagger is equal to G minus plus, right? This one, we will discuss chapter 5. Second one. Second one is G plus minus dagger. I mean, this is, even though I use this G1, G2, but the same thing, right? If I use I here. I mean, okay, use I. G1, and I. That's dagger equal to Y, right? Gi and I, G minus plus I. Sorry. Okay. Yeah. Right, it's just like you take this dagger means the head became bra and the operator became this dagger. So this dagger plus dagger itself. Dagger itself. Okay. And just like remember we have A dagger. A that dagger equal to A plus A dagger which is A, right? This is chapter 2. Cannot see.
I can if I lean down like I've lost my mind.
So I just use this. So now you can see here, G1 plus minus. This is applied bra. That's be like this. But this one is corresponds to the G plus minus dagger applied cat. And then after that, I take conjugate, right? So here, then that is become a G1 minus plus. G1 minus plus is not like this, if you remember, right? G1 minus plus is plus minus M1, G1 minus plus M1 plus 1. And drop. Okay, so G1, G2. But M1 minus plus 1 and 2. G M minus plus 1. That's the first term. The second term is G2. Okay. G2 plus minus M2. G2 minus plus M2. G2 plus 1. G1, G2, M1, M2 minus plus 1. Gn minus plus 1. So here, the reason why is because this one is applied block, so then this one be referred to as this dagger, which is this plus minus became minus plus. And then minus plus applied, so you have a minus plus here. That makes sense? Okay. So that is same like here. The only difference here we have this one, right? So now we can have the right hand side, the left hand side equal. Cancel the h part, we have a second division. So this is left hand side is g, g minus plus 1. Okay. Here. This I take first, right? G plus m, and g, here, this is minus plus m plus 1. And then the coefficient G1, G2, M1, M2, Gm. That's equal to, I use this base so I can have the motion for this. So equal to the two terms. First one is G1, this one, right? G1 plus minus M1, G1 minus plus M1 plus 1. G2, M1 minus plus 1. M2, Gm minus plus 1. Plus second term, G2 plus minus M2, G2 minus plus 1. So this is a second linear. First, okay, this is a bit complicated. You cannot remember. And later you will see. You have to remember this. Of course, you can go back to the textbook. But then keep in mind that you just know how to derive it. So now we have this tool. Okay, when we have this tool, now we can derive. Apply. So now how to apply? Apply the function relations. Let's see how can this relation help us. But first, let's apply the lower part. This is relation 1. When we say lower part, is we have a upper is a minus plus, right? Plus minus. Lower is we take plus here, take minus here, minus here. So we are going to take this one. Let's go on with this. So the lower part is the left hand side here, right? So this is G plus M, right? Here. Lower and G minus M plus 1. G minus M plus 1. G1, G2, M1, M2, Gn, lowercase, n minus 1, right? N minus 1. That's equal to here. Lowercase is minus, right? Plural. G1 minus M1, G1 plus M1 plus 1. And G1, G2, M1. Plus, right? Because lowercase is a plus. Plus 1, 2, Gn, M. Plus, second term, G2 minus M2, G2 plus M2 plus 1, G1, G2, M1, M2 plus 1. Okay. So we are going to use this. And how to use this one if, let's consider this case, if we select m is equal to j, and m1 is half, that's half, m1 is j1. So let's consider this case. Now, actually I need these two equations, but if you already write down, I can use those. You remember this. So if that case, let's see if I see this here. So now let's, we do here, so then in this case, okay, then here, left hand side is square root j plus m is j, right? Plus j. Okay. J minus m minus j plus 1. And then j1, j2, m1 is j1. How about m2? That is the first j minus 1. So here, this term, if m1 and this term is given m2 according to the selection rule, right? So select rule here, because this one plus this is equal to m minus 1, right? So now m1 is j1 plus something equal to j1 minus 1. So that is j minus j1 minus 1, right? This is the m2. Because you see j1, j minus 1 minus j1, that is the m2, right? Select, because I mean now that here, and here, so always keep consider. But this m must be here, but in this case, m is m minus 1. So m minus 1 here, that is j minus 1, for example here, j minus 1, right? And the m1 is j1. So m2 is moved j1 to the right hand side. So that is this. That means when you do this, be careful each term you can see you have to find this m. Okay, so that is the right hand side, right? Like now type space here. So now I can keep continuing. Hope you can follow. So that's equal, right? This is left hand side. Lower on the right hand side, now the square root j1 minus m1. m1 is j1, right? So that's equal to 0. But let's keep it. j1 plus j1 plus 1 and j1, j2. It is also makes sense because m1 is j1 cannot go over j1 plus 1. There's no, because that is m1 maximum value is j1, right? So definitely this term is 0, so no exists, right? No this term. But I just write down here, and this coefficient automatically give you no this term because this is 0, right? So, but since this is the first time, I write here m2 and keep m2 here, and jm. Because m2 here, I don't need to spend time to figure out. So now next, second term, this one, j2. j2. Now, this case, m2. So you see here, m1 plus m2 plus 1 equal to m. And m is j. That's it. So that is m1 plus m2 plus 1 equal to m, right? So m1 is j1, m is j, right? We select m equal j. Here, right? I select. So then m2 here, you move the m1 to here, that is j minus j1 and minus 1, right? So, but here, so that is minus m2 is j minus j1 minus 1. Is this right? The first one, j2 minus m2, and then j2 plus m2. So m2 is j minus j1 minus 1 and plus 1. Then here j1, j2, Okay, then M1 is G1, right? M2 plus 1. M2 plus 1 is G minus G1. Then G2. So now I can sum it here. Let's look at the left hand side. This is a 2J, this is 1, right? So the square of 2J. G1, G2. G1, M1 is G1, M2, G minus G1 minus 1. G minus 1. G and the M is G minus 1. Now this right hand side equal to the first term equal to 0, so second term, square root. Second term here. G2 minus G minus G1 and plus 1, right? Plus G, so this is a G2 minus G plus G1 and plus 1. Plus 1, right? Plus 1. That is first term. Second one is G2 plus G minus G1, right? G2 plus G minus G1. Okay. The coefficient G1, G2, then what's G1? M2, that term is G minus G1, right? G minus G1, G. Okay. So we can have, you see this one. Okay. Finally, you find the relation between this one and this one. Now, so we have this coefficient. So that is G1, G2, I think this is G1 and G minus G1 minus 1, G minus 1. This coefficient equal to a take a square root divided by this, it's 2G. And the numerator is G2 here, minus G plus G1 plus 1, G2 plus G minus G1. G1, G2, G1, G minus G1, G2. This is we call the equation 1. Okay. This equation we are going to use later, like here. So what does it mean? If we know this, right? If we know this coefficient, then we can go to add next one. Next one is what? Is m from G minus 1. Then m from G minus 1, then the G m1 doesn't change, so the G2 or m2 is also minus 1, right? From G minus G1 become G minus G1 minus 1. That is means if we know this, we can go to the next one, which is lower the m by 1 unit. So this equation we are going to use again here. Now that is we apply the lower part, right? So we can do the same thing, apply the upper part. That is second one, right? Apply the upper part. So I'm going to remove here, I just use upper, this is minus, this is a plus, this is plus, plus, minus, minus here, plus, minus, so we're going to use this with this, let's consider another case. With this, if we consider, since we are going to use this, if this known, and if this is positive, we can obtain this one. So if this 2 we know, we can go further. This one is changed to M2, right? Now, next one we are going to change is M1. Because here the M from G to G minus 1, and then if we fix M1, M2 will be reduced by 1 unit. But if this is the same, but I'm going to reduce M1, keep M2, then there's another one, right? So that means I have the coefficient of this states project to the basis is M1, M2, either M1 minus 1 or M2 minus 1. That is we use upper and lower in this case. So now let's consider. So if here, right, this is we select M equal to G and M1 equal to G1. So if still select M, but M is reduced, right? G minus 1. So I'm going to reduce by 1. And still keep M1 is G1. Okay. Yes. So now let's use this one. Then here, according to this, we have square root G minus M, right? Minus G minus 1. And G plus M is plus G plus minus 1 plus 1. It's a left hand side, right? Left hand side here, and then G1, G2, M1 is G1. Now I'm going to write down here. G, so M is G minus 1 and plus 1. And how about the M2? G minus 1, right? This is G, M minus 1, right here. M is G minus 1. So N, sorry, this is minus. I use lowercase b plus. Yeah, use a plus. Uppercase, right? Use a plus. So that's plus 1. So G minus 1 plus 1 is G, right? This is G. This is G1. So here, so G minus G1, right? That is M2. Okay, keep this and that equal to, that is right hand side square root, G1. Now this is plus, right? So plus M1 is G1. Then G1 minus M1 is G1 plus 1. G1, G2. M1 minus 1, so the G1 minus 1, right? And M2 I keep here. So then M is G minus 1. Then M2 is G minus G1, right? Because here. And minus 1. Yeah, here. So it's G minus 1. Yes, that's correct. And plus G2. Now G2 plus M2. And we can keep here. So what is M2 here? G1, G2. And M1. Here is M1, right? M is G1. And M is G minus 1. So here M2 minus 1 should be equal to M2 minus 1 equal to G minus G1 minus 1. G minus G1 minus 1. Then M2 should be G minus G1, right? So that is here. G minus G1. That's M2. G2 minus G minus G1 plus 1. This is a little complicated, so be careful here. G1, G2, M1 is G1, and M2 minus 1. Oh, no, over here. Okay, in this case, right hand side is this one, actually, now right hand side is square root. So here, G minus G minus 1, that is 1. And then G plus 2G, so that is 2G. Square root 2G, right? 2G and G1, G2 here, and G1, M2 is G minus G1, and G. Right? Here, G minus 1 plus 1 is Gg, so that is right hand side. Right hand side here is 2G, so that is square root 2G1. This cancels, right? So 2G1 and G1, G2, G1 minus 1, G minus G1, and G minus 1. First, second term, activate square root G2 plus G minus G1, and here G2 minus G plus G1 plus 1. Multiply G1, G2, G1, G minus G1 minus 1, G minus 1. Okay, now we know this. If we know this, right, so that is the first one. If we know this, we can know next one. If we know this, next one we know this, so now we are going to try and find this one. We have 3 coefficients, but starting from this we know, then for the first equation we can get this one, second equation of this. So we have the second equation is for the next one, G1, G2, G1 minus 1, and the G minus G1, G minus 1. This coefficient we can obtain equal to, okay, here the first one is square root 2G divided by square root 2G1, so that is square root G1 divided by G, right? And the coefficient here, G1, G2, G1 minus 1. Just opposite. I need this one, so I move this to the right hand side. So now that is divided this G divided G1. This one also G1, G2, G1, G minus G1, G. Second term is this one divided by this, so we have plus square root G2 plus G minus G1, G2 minus G plus G1 plus 1 divided by G1. Okay, and the coefficient is next one. Is G1, G2, G1, G minus G1 minus 1. G minus 1. Use this is a equation. Equation 2. Alright. So by applying the recursion relation, we can obtain this, and you will see here with these 2 equations we can get all these remaining coefficients related to this. So from here, if we know this, then we can find this m from G to G minus 1, the coefficient for m2 minus 1, and another coefficient for m2, m1 minus 1. So that means you know this, we can know this. Then you can go further. If m, you suppose this G1 by G by 1 by minus 1 by m, another m, then you can do the following. So this is the way I will not spend too much time on here. I will spend too much time here. Right? And then next, as I give you this one, you are going to use this table. If they, you can apply the table, not list all of them. We have a sum of half or one or half three half of that one. So if that case, you can use that one. And if not, you have to go to this kind of recursion. Now let's do examples. See how we apply. So far we discussed addition of angular. We have two angular J1, J2, and add together J. So how to obtain the eigenvalue allowed eigenvalue for G and M, and then what is the joint eigenstate? How to obtain the joint eigenstate? We need the coefficient, CG coefficient. Now let's do example. So like this. Example, consider we have S1, two speeds. Now we are going to see first one, addition of these two speeds. So that is what we are going to do, the addition of these two speeds. So now we are going to ask ourselves is, okay, so if S1 equal to S2 equal to half, let's consider. So that's given, right? And all these cases given G1, G2. Otherwise, there's a lot of unknown, right? So for given G1, G2, we know the spin, the magnitude, and then the remaining part, addition of the two, depend on the rotation or angle between these two. That is all the allowed S, right? So now, if this is the case, and you know M1S is plus minus half, M2S is plus minus half. This is, once we know this, we know that. Now we are going to find the allowed S and MS. How to determine this? That's the eigenvalue. So, as we already know, the allowed S to be always smaller than S maximum and larger than X minimum, right? That is allowed. For all these allowed S value. Now what is maximum? What is minimum? Maximum is S1 plus S2, right? So this formula. So you immediately obtain this, okay? You are going to find allowed value of S. So in this case, S S. So this one is half plus half equal to 1, right? This one half minus half equal to 0. So S is from 0 and 1. Only is two values. Right? So then S equal to 0, MS is equal to 0. Because for MS always in this case, right? So that means we have two allowed values for S, 0 and 1. For S equal to 0, MS only 0. Now S equal to 1. So MS is 0 and plus minus 1, right? So you obtain this immediately have eigenvalues. Second one is eigenstates. We are going to obtain eigenstates. Yes. How many eigenstates? Because we form this space by allowed S value and the MS value for giving S1 and S2. This is for allowed, this is the eigenvalues. Analyze eigenvalues first, then now that's this. So now we have S, MS, with how many states? Depending on S and MS, right? So first case, S equal to 0. Then we have MS be 0, so this states. Then second one, S equal to 1, MS 0 plus minus 1, we have 3 states, right? So totally we have 4 states. Okay, these 4 states, if you're familiar with this one, like, because this means MS 0 means MS 1 plus MS 2 equal to 0. So there's only these states, right? This is MS1, M1S, M2S, 1S, M2S. So we call it singlet states. There's only one, right? That this single state, either this two spin always enters the opposite direction, right? If M1S up, M2S is down, or MS down, M2S up. Now this is single state. So this three correspond to this one all up, right? Because if MS equal to 1, M1S plus M2S equal to 1, those all add up, right? And another one is this correspond. Now this is correspond. This one is correspond to this states, and another is all add up, right? Correspond to 1 minus 1. So these three states we call triple. We have three states depending on the orientation, occupation of the spin of these two. Now that is the eigenstates. Now we are going to find the Clavish coefficient, so we can express these four states in terms of the product of S1, M1S, and S2, M1S2, M2S, right? So now this is states we all know. 3, find this coefficient. That's here. So because for any states we know, we can using combination of all these M1S, M2S, and M1S plus M2S equal to MS according to selection rule. And here this is S1, S2, M1S, M2S, S, MS. That is this formula, right? So let's consider for each case. S equal to 0, MS equal to 0, equal to, so now here, if MS equal to 0, we already show here, there are two possibilities. Either the first one is up and the second one is down. So this summation here, if we select M2S is down, M1S is up. Another is M2S up, this be down. So there are two terms, right? No other others. Only two terms, right? For this summation. So here, let's consider first one, S1, S2. If M1S is up, then M2S is down. 0, 0. So. Actually here, because we know S1 and S2 is half. Half. And then here, this is a half minus half. Second term is M1S is negative and M2S positive. So we have two coefficients we are going to determine. Let's first write down this, and then we are going to calculate this. So now let's consider 1, 1. Similarly, right? Similar to 1, 1, and we will follow this. So 1, 1, this means MS equal to 1. So M1S half. Sorry, M2S also half. So this summation only one term, right? There's no any more term. So that will be half, 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 half. And 0 of 1, 1. And this one, okay, later on. So let's first write down all these states in terms of the Clavish coefficient. This one again like this. If MS equal to 0, so there are two choices. M1s up, M2s down. So that's how it works. Plus now the last one, 1 minus 1, as I said, if ms equal to minus, so m1s, m2s be all down. Therefore, there's only one coefficient. This is a way we first analyze each state in terms of Lebesgue-Golden coefficient. Right? This is a C S1, S2, S, N1, S, N2, S, S. Now the remaining geometry we are going to obtain 1, 2, 3, 4, 5, 6. We have 6 coefficients we need to obtain, but you will see there are 2 just a limit case, so we immediately can apply this Lebesgue-Golden coefficient. There are 2 limits is equal to 1, right? So now let's do the first. This one. This one is 1. This one is also 1. That is correspond to J1, J2, J1, J2, J1 plus J1, J2, J1 plus J2. This equal to 1. So we have this. Then we have a remaining 4. Let's do one by one. So now we're going to calculate 4. Okay. First one, A. Let's do this one first. You might find out from here. From here, we can apply the equation we derive. From here, it is not easy. We are going to use another technique. So from this example, I just let you know there are several techniques we can apply to obtain this CT coefficient. So now let's do one by one. Here, for this one. Okay. For this one, this is M1, right? So for this one, you can see if this, if this is J, this is J minus 1, right? So we are going to find J minus 1, and here, if this is M1, which is J, then this is J minus J1 minus 1 is like J. So we are going to apply equation 1, which I just let me write down equation 1. Equation 1 is J1, J2, and M1 is J1, but M2 is J minus J1, right? Minus 1. Minus 1. J minus 1. That's equal to square root 2J and J2 minus J plus J1 plus 1. J2 plus J minus J1 and J1, J2, J1, J minus J1, J. We're going to use this equation. Here, the reason here you can see this one, if J is 1, then this is 0. So that is this, and then you can see here, if J1 is half, right? So that is half. Then you can see here, 1 minus half is half. Minus 1 is minus half. So this one is this. That makes sense? Okay. So now, if we know this, then we can obtain this. So now let's do. So apply this. So we have, okay, the left hand side is half, 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 minus half, 1, 0. In this case, is equal to square root 2 multiply 1. J is 1, right? this case G is 1. And square root, G2 is half, G is 1, plus G1 is half, plus 1. And this one, G2 half, plus 1, G is minus half. Then now here this sticks, so this G1 is half, G2 half, G1 is 0 half. This one, G is 1, minus half is half, right? Okay, G is 1, 1. Do we know this? It is this limit, half limit. This is when m equal to G max, G equal to G max. And then this m1 is G1 max, m2 G1 max, right? So that is 1. So then the remaining is, now you can see here, this is a minus, so this is 1, right? This is so that 1, that is only 1 over square root. Fantastic, right? So we immediately obtain the first coefficient if we apply the equation, which is direct. So that equation is important. Now we obtain this. Let's go to next one. B. We are going to obtain the next coefficient here, right? So this one, the first one obtained, now we go to this one. And you can see this one actually is equation 2. This is m1 minus 1, that term. So that m1 is G1 equal to. So now let's consider this term. Now we are going to apply equation 2. So to remind you, equation 2 is G1, G2, G1 minus 1, G minus G1, G minus 1. That's equal to square root G over G1, G1, G2, G1, G minus G1, G, minus. Oh, I think I did make mistake. There's a minus because I moved term. If I forgot, make mistake, so this will change the sign. I move that term to the right hand side. Right hand side. G2 plus G minus G1, G2 minus G plus G1 plus 1 divided by 2G1. And this state is G1, G2, G1, G minus G1 minus 1, G2. Okay, we're going to use this. Now how to use this? Let's see how to type. So now here, right? So G1 is half, G2 half. G1 minus 1 is half, right? Sorry, minus half. Half minus 1 minus half. This one, 1 minus half is also half. 1, 0. That is this term. That is this one, right? Okay, right? So right hand side, yes. Now right hand side, now here let's square. G is 1, right? G1 is half. And then this one is a half, G1 being half. This is a 1 minus half, so that is half. 1. G is 1, right? And minus, okay, this term is half plus 1 minus half minus 1 plus half plus 1 divided by 2 multiplied half. And then let's say half G1, right? So that's the half. This one is minus half. 1, 0. This is a square root 2, right? This one. But that is the maximum limit. In this case, it's the limit 2, 1 up to, so that is multiplied by 1. And then here, this is cancelled. And this one, so this is 1, right? And this is 2, so that is, I think the square root. This one minus this is 1. This is another one. Yes, that is 1, right? So that is minus this one. This one we just open here. So that is 1 multiply 1 whole square 2. This one. Then we have this one minus this one is 1 whole square 2, right? Fantastic. So this is the way to obtain these two coefficients, use the equation 1 and 2 to apply the Kirby relation. Now we can have another method I want you also learn to obtain these two. So we can use this space. See another method. Sometimes this one is works. Another method is we are going to apply this operator, apply these states, give us this S minus S1 minus plus S2 minus applied states. And this states is also equal to half. We have here. See this states. Y1 is equal to here, right? Because the coefficient is 1. So I just take here, apply the S minus left-hand side, right-hand side. I'm going to use this solution. So let's go to the right-hand side. Right-hand side, S minus, apply this. We have to give us H bar, there it is, right? S minus plus, right? S plus and S. I just gave you a formula, then we are going to substitute the numbers. S minus and S plus 1. And here, this to S and N S minus 1, right? And in this case, MSS is 1. So that is 1 plus 1. 1 minus 1 plus 1. 1, 0. So that is this term, right? And can I erase this part? Set is okay? Okay. So that is the left-hand side. Now let's do the right-hand side. Right-hand side is S1 minus plus S2 minus apply this. So this one, S1 minus only apply the J1, S1 and M1 S1, that term, right? So that's equal to S1 minus apply this one is S1 and this one is M1S. This only applied because this is in the subspace, independent subspace. So each operator only applies themselves in this subspace. Then each one, this one follows the same thing, right? So now we have H bar. S1, I just write the formula and then you do the number. S1 plus M1S, S1 minus M1S plus 1. And then here, H bar follows. So this states here is S1 and M1S minus 1, right? And multiply, not plus. Here is multiply. Multiply H bar S2 plus M2S, S2 minus M2S plus 1, and then S2, M2S minus 1. So let's write down here. So we have an H bar square. I think I have. Oh, sorry, that is my mistake. This is plus here. That is my mistake. Let me do it. Okay, sorry. I thought it's product. That is the next question I will do. Plus S2 minus will vote on this. Now let's go to H bar. S1 plus N1S, S1 minus N1S plus 1. And then this one state is half NS, and then it's minus, right, because it's minus half. And then the second state will not change since we did apply this S2. And the second term is only S2. S2 plus N2S, S2 minus N2S plus 1. And then the first one we keep here, the second one, N2S from half to minus. So now let's organize here. The left-hand side is square root 2 h bar by 0. The right-hand side h bar. The first one, sorry, I didn't set it. Okay. Again. So here, half, S1 is half, right? M2 is also half. And this is a half minus half plus 1. This is a half minus half. Second term is h bar. Half plus half. This is half minus half plus 1. Half minus half. So now I have a right-hand side is h. This is a 1. This is also 1, right? So that the h bar 1 is half minus half plus half minus. So now, that means this states, I'm going to divide it square root 2 h bar cancel, right? And both sides, 1 over square root 2. I think you already clearly see this, what is. This one is this coefficient right here. Because this states half minus half is this one. So that's be correspond to this. And the second one, this coefficient be correspond to this this one, right? Because it's half minus, so that is what immediately we have the coefficient half minus half by 0 equals to 1 over square root 2, and half minus half by 0. So that, in this way, you immediately obtain this 2. And the way is that, since when we apply the left-hand side, we got states. This state is the joint eigenstate list. Then if we have the linear combination on the right-hand side, that coefficient should be correspond to the CG coefficient. Sometimes this one is better, maybe if it's simple, right? So that instead of to do those equations, you can just apply. Not apply this recursion equation, you can apply this way. So it's up to you if you just analyze which way is better for you to obtain. Okay, so that is the second method. Now we can go to answer this question. These two coefficients we have not obtained, right? To obtain these two, we need some other technique. Okay. So now we are going to for, I think ABC, right? So that's the B. Now we are going to for this coefficient. Half minus half, 0, 0. And I'm going to do this together. And half minus half, 0. For these two, we're going to do together. We apply what? We're going to apply the eigenstates is orthogonal and normalized, right? Apply the normalization of. Let's do this. So this is states. This state, these two coefficient states for this state, 0, 0, right? So now let's see if we have this first needs to be 0 because they are not the same state, right? So if I use the 1, 0, inner product between 1, 0 and 0 needs to be 0. So now we're going to apply this. Okay, so now since 1, 0 we already obtained, right? It's here, right? 1, 0. So since 1, 0 is square root 2 half, half, half minus half plus minus square root 2 half, half minus half, half. And 0, 0 is, we do not know, which we are going to obtain, right? Half, half, half minus half. 0, 0, half, half, half minus half, plus half, half minus half, 0, 0. Is this the first one? So this one and this one. So we just apply this by inner product. So 1, 0, 0, 0. Then you can see here, the graph will have these states because orthogonal. This also orthogonal with itself, right? So we have square root 2. Inside is half, 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 half minus half, plus half, half minus half, half. This graph, this 2 graph. Multiply this one, right? If I use, I just want to save time. So this is A, this is B. So that is multiply A, half, half minus half, plus B, half, half minus half. That is inner product. Then we know the orthogonal, so this states, this one equal to 1. But this states, orthogonal with this one, so that's 0, right? So then we have square root 2a, right? That is a. This one gives this one a. But this term outside is 0. Second term, this one orthogonal with, so that is plus b, right? Equal to 0. So we have a first relation a minus b equal to c. The next one, we are going to use a normalization of 0, 0. This is equal to 1, right? So now I already used a and b, so that means a squared plus b squared equal to 1. Right, so now if I here, this one, so no, I use this coefficient of a, right? So a B is minus a, right? So a is minus square 2. And just then b equal to minus a minus square 2. So we immediately obtain this. Then finally, this state is square root 2 half, half, half minus half minus half, half minus half. Now we can double check by the table, which you have it with your hand. If not, you can check the table. Now this case is just first corner because S1 half, S2 half, right? The corner you can see here, we have 4 states. Then S is 1, 1, so that is 1, 1. Then you look at the coefficient here, that's B1. So let me just do here. Half, 1 over half, this table. Now, the first, this is an S, this is an S, let me just, this is an S and MS, right? So that is this case. This case, this is M1, S is half, so M2 is a half, right? There's no any other, so this is a 1. The next one is correspond to 1, S1 and 0, 0, 0. Okay, this. The first one is this state, right? The second one is this one and this one. So this one and this one, for states, you will have two possible. Zero, zero, zero. So we have each one be always opposite, down and up, right? So when M1 S is down, then you have a half, but you have to take square root half. And this minus half, half. This is a half, minus half. But you have to take square root. Here, it's just a number. So that is, we obtain here, right? This state and this state. This state, they have a minus sign. This state have a phone sign. And the next one is 1, 1. 1 minus 1. In this case, we only have a coefficient half, minus half, minus half. And that all consistent. So I just let you know how to use the table. Let's start the next one, and we can now finish, but I think we have to do that. All right, so that is the exercise how to obtain the coefficient. Now the last one, if asked her to calculate the such terms, how to do that. So I think it's number 4 or number 4, number 5, right? So now how to calculate S1 inner product is S2 of prime states are 0 and S1 plus S2 minus are 0. How much? How to do this? We are going to apply this the behavior of these states. So the first case is this one. I think this last semester we have some of exam, final exam. Something like this, ask you to calculate this eigenstates of this product of these two. So this state is S square, S1 square, S2 square, and SZ, but not S1, Z, not S2Z, right? So you have to try to manipulate this one in term replaced by the S square, S1 square, S2 square. If you agree. Do you agree? Because S square is equal to S1 plus S2 square. So that is S1 square plus S2 square and the inner products, since they commute each other, right? Twice. So when you deal with this, you just replace this in terms of this. Now this is the eigenstate of this. So very easily you can obtain. I just occupy this one. 1 minute. 1, 0 is half of S square minus S1 square minus S2 square apply the states, and this one half of H bar square. This is S plus 1, right? Minus H bar square S1 plus 1, and minus S bar square S2 plus 1. And then you just substitute S equal to 1, S1, S2 are half. So finally, you will find you get this one. Okay, then the next one, I want you to think about this, and we can continue do that on next Monday.
Zen.
That's right.
这个你那个你没可能，好不好？好。
Hey, Zen. Get Zen. Get Zen. Get Zen.